As the value of energy increases every day, along with awareness of environmental footprint, utilities globally drive for development of solutions to improve electrical network efficiency.
Whether a demand from regulation authorities, a conscious effort to reduce environmental impact, or economical calculation, the drivers to tackle technical losses on networks are pressing for the embrace of better practices and smarter solutions to build networks.
Benefiting from a long tradition of high-quality, high-efficiency product, CCAM strives to support utilities in this effort to make overhead distribution grids more efficient. I would like today to focus on technical losses induced by low-voltage connectors and how we, at CCAM, propose to address the matter. This will be as well an opportunity to present the TTDneo range, a comprehensive line of highly efficient connectors specifically enhanced to minimize network losses.
As any one component of the network, low-voltage connectors contribute to overall technical losses through their own resistance. This resistance, from a few microohms to a few hundred microohms, may vary due to design. As an example, a 150 microohm network connector seeing 100 amps in average will act as a 1.5 watt ever-turned-on heater, consuming 18 kilowatts in a year, 500 kilowatts in its lifetime. If that connector was replaced by a 30 microohm connector, the losses would be reduced by 80%, saving 400 kilowatts over its lifetime. This energy saving is equivalent in order of magnitude to replacing of a traditional light bulb by a CFL one. Considering that each utility installs typically hundreds of thousands of LV connectors on their networks every year, this is easy to imagine how much energy savings is at stake. Despite compliance to common standards, connectors are not born equal when it comes to electrical resistance. To qualify for a given standard, ANSI, EN, NFC, connectors' electrical performance is usually assessed by a heat cycling test, aka electrical aging. Heat cycling test is helpful to validate a connector will fulfill connection over time. It does not, however, provide indication of the connector's efficiency. Indeed, in heat cycling test, only resistance evolution is assessed, not the resistance value itself. For instance, the resistance at the end of the test shall not be more than 2 times the initial resistance, or resistance shall not increase by more than 15% over the last 750 cycles. These criteria are helpful to ascertain stability over time. But, ironically enough, heat cycling test will favor, within limits, connectors that present high resistance rather than efficient connectors. For instance, a connector presenting an initial resistance of 100 microohms will pass with an increase of 14 microohms over the last 750 cycle. On the contrary, a connector starting at 10 microohms may fail the heat cycling test with only an increase of 2 microohms over the same number of cycles. While heat cycling test is appropriate to make sure a connector works over time, it is not collateral with efficiency. In order to target efficiency, a connector needs low resistance absolute value, easy and repeatable installation on the field, full water tightness to prevent contact deterioration and corrosion over time.
In order to support better efficiency of distribution networks, CCAM introduces a renewed line of IPCs, TTDneo. Complement to the standard TTD line, Neo products have been further enhanced towards high efficiency throughout their lifespan.
When compared with other leading brand IPCs, TTDneo performs with up to 4 times less resistance than other brands' products. For both network and service applications, TTDneo range offers very low resistance solutions to boost the LV distribution network efficiency. While high-efficiency connectors as TTDneo may be slightly more expensive for the strict selection of material and craftsmanship associated, the return on investment of installing these connectors can be as low as 2 to 3 years for a lifespan of 30-plus years. A case study shows that for a medium-sized network presenting 3.5 million LV network connectors, the use of TTD301neo instead of the average alternate network connector may save to the utility about €1 million per year.
Losses in LV distribution networks is no small change. It is a real, measurable problem that more and more utilities are encouraged to address. If LV connectors represent only a minimal 3 to 4% of the overall line cost, their impact on line efficiency and reliability is crucial. TTDneo is a simple, comprehensive solution to address this issue, reduce LV network technical losses, and become the flagship of the TTD range promise. Highest quality, easiest installation, longest lifespan, and best overall cost for utilities. Thanks for your interest and have a great day.